article talk for other uses. See intensity disambiguation. In physics, the intensity or flux of radiant energy is a power transferred per unit area, where the area is measured on the plane perpendicular to the direction of propagation of the energy in the SI system. It has units watts per square meter or kgs minus 3 in base units. Intensity is used most frequently with waves such as acoustic waves, sounds, or electromagnetic waves such as light or radio waves, in which case the average power transfer over one period of the wave is used. Intensity can be applied to other circumstances where energy is transferred. For example, one could calculate the intensity of the kinetic energy carried by drops of water from a garden sprinkler. The word intensity as used here is not synonymous with strength, amplitude, magnitude, or level, as it sometimes is in colloquial speech. Intensity the word intensity as used here is not synonymous with strength, amplitude, magnitude, or level, as it sometimes is in colloquial speech. Intensity can be found by taking the energy density at a point in space and multiplying it by the velocity at which the energy is moving. The resulting vector has the units of power divided by area, surface power density. Mathematical description: if a point source is radiating energy in all directions, producing a sphere wave, and no energy is absorbed or scattered by the medium, then the intensity decreasing in the proportion to the distance from the object squared. This is an example of the inverse square law. Applying the law of conservation of energy, if the net power emanating in constant P is equal to integral I dot dA, where P is the net power radiated, I is the intensity vector as a function of position, the magnitude in the intensity as a function of position, and dA is a different element of a closed surface that contains the source. If one integrates a uniform intensity constant over a surface that is perpendicular to the intensity vector, for instance over a sphere centered around the point center, the equation becomes P is equal to I dot A surface tension is equal to I mod dot 4 pi r square.